Hey guys, I'm going to be introducing you to how to multiply polynomials. Yes, we talked in the last set of notes about multiplying a monomial, but what if we have more than one term times a polynomial? How does that change things? So I'm going to start with and this should be about 1 page long, but if I have to take 2 screens, I'll take 2 screens. But the main thing I'm going to do is to share with you a third strategy. So in the prior notes, we talked about the horizontal method, the vertical method, but I want to introduce you also to the area model, or as I lovingly call it, the matrix. So we're going to take one problem. So to try to relieve my issue with doing work on 2 pages, 2 screens, because of the way that my screen is set up, I'm going to use my left side and my right side, okay? So this is I have 2 terms, that's a binomial, and I want to multiply a binomial times a binomial, okay? So let's review how I would do it with the horizontal method. So I take those 2 binomials, and I'm going to multiply everything of one polynomial with everything from the other polynomial. So it's going to look something like this. I'm going to take the 2x and I'm going to multiply it by the 4x squared. And then I'm going to write always plus, and then I'm going to multiply the 2x times negative 7. Okay? Then I'm going to be multiplying the 3, positive 3, so plus, and I'm going to multiply 3 times the 4x squared, and then I'm going to write plus again, and I'm going to multiply the 3 times the negative 7. Okay, now, when I multiply, I get 2 times 4 is 8, x times x squared is x cubed, and then 2 times negative 7 is negative 14x. 3 times 4 is 12, and then we have x squared, and then 3 times negative 7 is negative 21. And the only thing I would do to my answer is make sure that it is in standard form, and then it makes it a little easier to look for any like terms. So remember, the sign that's in front of a term travels with that term. Now, I don't have any like terms. I don't have any variables with the same exact exponents that I could combine together. Now, some of your parents or older siblings may call this FOIL, but I'm going to tell you FOIL is a strategy that's great if you only have a binomial times a binomial. And so it's like first, outer, inner, last. But this is the same thing, basically. All right, so then we had the vertical model. And we're going to take those same 2 polynomials, and we're going to put one on top and the other on the bottom. Now in this case, because they are both 2 terms, it really doesn't matter who goes where. And then we're going to multiply these. Okay, so how we're going to work it out is we're going to multiply the 3 by the negative 7, so I get negative 21, and the 3 times the 4x squared, so that's going to give me a positive 12x squared. Then I'm going to multiply everything on the bottom. So what I do when I get to these bottom ones is I'm going to line them up with like terms. So I get a 2x times a negative 7, that's going to give me a negative 14x. So notice I'm squishing it between those 2. And then 2x times 4x squared is going to give me that 8x cubed. So I'm kind of putting it into standard form as I'm doing it. So then I just kind of add up any like terms, which in this case I didn't have any. I didn't have any numbers that were in the same columns. And I ended up with 8x cubed plus 12x squared minus 14x minus 21. So this one gets a little bit messy in that sometimes I'm squishing terms between, but I'm on different layers, so it's not so bad. Sometimes what people will do when they notice there's a gap from a constant to a squared term, they'll put a kind of a big blank spot for it. But my favorite method, not to show favoritism, but I am, is what we call the area model. Or the matrix is what I like to call it. Don't ask me why. You do deal with matrices later on, so this is probably bad for me to call it this. So basically what we're going to do is to create a rectangle. Could be a square, depends on the shape, but a square is a rectangle, with length that's equal to the number, oh sorry, forgot some words there. Equal to the number of terms in one polynomial and the width equal to the number of terms in the second polynomial. Now you might be going, what? But once you see it in action, you'll understand what I'm talking about. What I like about the area model is things like the FOIL only works for binomial times a binomial. Area model works for any type of polynomial times any type of polynomial. So let's take R2. So I have a binomial times a binomial. So that means I'm going to end up with a 2 by 2 box. And all the work's going to get contained in the box, and then I'll write my answer below it. So it doesn't matter who goes on top, but make sure you attach signs for each number. So 4x squared minus 7. So notice the 2x squared and the 4x squared don't have a sign. We can assume they're positive, but I want to make sure that you understand that we have a positive 3. So now what I'm going to end up doing, and I'm just going to do this first time. The rest of the time I'll do the math in my head. This is going to be 2x times 4x squared. Okay, so that's going to give me 8x cubed. To the right, I'm going to have 3 times, sorry, let's use the dot, 4x squared. And that's going to give me 12x squared. Okay, now I'm going to multiply the 2x and the negative 7. So I'm basically figuring out the area of each of those smaller rectangles. So then I have 2x times negative 7, which is going to give me negative 14x. And then I'm going to go ahead and multiply the 3 times the negative 7, which is going to give me a negative 21. So now what I'm going to do is take those terms and I'm going to write them in standard form. 8x cubed plus 12x squared. So if you don't see a sign, it's got to be positive. Minus 14x minus 21. So if you're one of those people who's not really good about putting your signs in, you may struggle with doing our math. Okay, I'm going to try to fit in 3 more examples on this particular strategy. You can use any strategy that you want. Directions are going to say find each product. So I'm going to do 1 underneath the directions and then 2 at the bottom. So you don't have to do my strategy, you can do any strategy you want. So first one, we're going to do 2x plus 3 times x plus 5. So it's going to be a 2 by 2 box. Now, something happened in the last one, but you didn't really see it. But it will show up even more clearly here. So all I'm going to do is my math out. So in my head. So in this box, the top, upper left, I have 2x times x. That's going to give me 2x squared. And then to the right of that, I have 3 times x is going to give me a positive 3x. At the bottom, I've got on the left 2x times 5 is going to give me a positive 10x. And then the bottom right, 3 times 5 is a positive 15. Okay? Now, what I want you to notice is check out this diagonal. If your polynomials are in standard form and you're not skipping over any degrees, okay, you should find like terms on that edge. Okay, so these are like terms. The only time it may not work, like look here. There were not like terms. Why? Because this guy on the left went from 4x squared to a constant. Okay, so I'm going to erase that. So then I'm going to add those up, and this is going to give me for my final answer, in descending degree order, 2x squared, 3x, and 10x is 13x plus 15. Bam. All right, let's do another one. So we have x minus 2 times 3x plus 4. So again, it's going to be a 2 by 2 because I have 2 terms by 2 terms. So x, and actually let me switch this around. And it doesn't matter which one goes vertically and which one goes horizontally. Okay, so in the upper left-hand box, 3x times x is 3x squared. To the right of that, 4 times x is 4x, positive 4x. Bottom left, 3x times negative 2 is negative 6x. And then bottom right, 4 times negative 2 is negative 8. So we look on that diagonal. And we do have like terms, so I'm going to write my answer out at the bottom. Standard form, 3x squared. Let's say I get a negative 2x minus 8. All right, last one. We're going to go big. 2y squared plus 3y minus 1 times 3y squared minus 5y plus 2. So the question we might be asking is, are we going to see that same idea of like terms being on a diagonal? So let's watch this. But now my box is going to change. It's not a 2 by 2 anymore. It's a 3 by 3. Why? Because I have a trinomial times a trinomial. 2y squared plus 3y minus 1 on the top, 3y squared minus 5y plus 2. So notice that each of the polynomials are in descending degree order with no skipping of degrees. Okay, so let's go ahead and multiply. We have 2y squared times 3y squared is 6y to the 4th. I have 3y times 3y squared is going to give me, put a positive, positive 9y cubed. Negative 1 times 3y squared is negative 3y squared. Now we're going to go to the second row with a negative 5y. So negative 2y squared times negative 5 is negative 10y cubed. 3y times negative 5y is negative 15y squared. Negative 1 times negative 5y is positive 5y. 2y squared times 2 is 4y squared. 3y squared times 2 is going to give me positive, 6y. And negative 1 times 2 is going to give me a negative 2. So let's check out those diagonals. There's nothing else that says y to the 4th, but look at here. We do have 2y cubes, and then look here. We have 3 terms that say y squared, and then look here. We have 2 terms that say y. So yeah, it does work. That's why I love this method. So what do we have? We have 6y to the 4th. Let's see, we have negative 10y cubed, and positive 9y cubed is negative y cubed. we have 4y squared minus 15y squared, so that's negative 11y squared, minus 3 gives me negative 14y squared. You could just combine the negatives and say, oh, I have negative 18y squared, and then subtract the 4 from it. Same thing. And then minus 2. Oops, nope, sorry, went too fast. Then we've got 5y and 6y is a positive 11y, and then minus 2. And there's your answer. All right, so again, you're not forced to use any one particular strategy, but I really encourage you to try out this area model because it will have some practical applications as you go into your next level of math classes. All right, that's it for today, guys. See you later. Bye.